DCO Analyzer is a tool used in distributed systems testing. It helps you check if a given system is locally observable and controllable. And if it isn't, our program can provide you with the minimum number of coordination messages needed to achieve these properties. So what is a distributed system, and why are these properties important? A distributed system, as the name implies, is a system made up of many distributed components. These components can communicate between one another through messages. To make sure this type of system is working as intended, it's often used a method of testing that places local testers in each of these components. A central tester then sets up these local testers with given scenarios, so that they may find any potential errors with the components. In order to make this process time and resource efficient, the local testers must be able to run as independently as possible, so that they don't needlessly weigh on the central tester or other test components. To do this, they must keep their communications or coordination messages as low as possible during the whole testing process. So what does it mean for a system to be locally observable and controllable, and how does it contribute to minimizing these messages? These two properties guarantee that each of these local testers can read and operate their assigned test independently. Local observability means that the local testers can detect any conformance errors by themselves, while local controllability means that the local testers can all choose their own test inputs independently. Both of these are crucial properties in keeping coordination messages low and the whole test running as quickly and efficiently as possible. So how would one use DCO Analyzer? Let's say you're a test engineer looking to test some scenarios, or a system designer in need of some help. First, you would open your favorite UML sequence diagram editor and draw your system. Then you would open up DCO Analyzer and upload your diagram. If it complies with the UML meta model, you'll be able to analyze the following properties: valid traces, unintended traces, locally uncheckable traces, local controllability, local observability, and coordination messages. Let's try running this diagram through our program. There, see? We found an issue. This diagram isn't locally controllable. Luckily, DCO Analyzer shows us how to fix this problem, so you can get right back to the drawing board. DCO Analyzer is a must for test engineers working with distributed systems. It's the first tool able to automatically analyze properties such as local controllability and observability, while suggesting the minimum number of coordinating messages to correct these problems, thus making the scenario apt to be tested in a distributed manner. You can find and learn more about it on the address you see on screen.